All right, today we're going to talk about factoring trinomials where our a value can be anything. Meaning that it doesn't have to be, the ones we've worked on these last couple days, we've always had that a value equal to 1. So just a reminder where that a value is. It's when we have it in standard form, we have ax plus bx equals c. So everything we've done up till this point has had that a value of being 1. X squared plus 7x plus 6. Something like that, where that a value is 1. Today what we're going to work on is we're going to work on, okay, what happens if that a value isn't 1 and we can't factor out a GCF or do anything really like that. What the heck is that? So, for example, I mean, I did one of these with you yesterday. We talked a little bit about this yesterday. Okay, we talked a little bit about this yesterday, and we talked about how we're going to do these. We did that one question where I broke it up and kind of split that middle term and did this factoring by grouping. And that's how we're going to treat these. So let's just dig into it. So trinomial that we're going to use, that we're going to kind of start out with. We're going to start out with 3x squared plus 10x plus 8. So now because that leading coefficient, our a value, isn't 1 anymore, we have to look and see if we can take a GCF out. Let's put our phones away, guys. This is stuff that's getting up into a whole lot more difficult stage. We have to look and see if we can take out a GCF. So if we look at our numbers, 3, 10, and 8, they don't have a common factor, so there's no common factor to take out. All right, so now we kind of go into our mode from yesterday a little bit. So we know we're going to break this up into 2 binomials. But now, and don't write what I'm about to write in your notes. But now, like yesterday, we put x and x, right? If I put that x and x there now, if we FOIL it out, if I were to kind of start to FOIL this out, x times x gives me x squared. Well, it doesn't need to be x squared now. It needs to be 3x squared. So that part of the process is going to change a little bit. We really are not going to do that piece of it. And in fact, we're really going to kind of take this and get rid of that part of it as well for now. What we're not going to get rid of with the leading coefficient isn't 1 is we're not going to get rid of not doing the x method. We are going to continue to do this x method. Now, when we talked about this x method the last couple of days, we always said that this top part was a times c, and that's not going to change. But again, the last couple of days, we've really just looked at our c value because that was the only thing that was there. Now we have to look at both the a value and the c value. So in this case, our a value is 3, and our c value is 8. So the number that I'm going to put in the top now is 24. That's my a times my c. The bottom term, we always said was the b value. That's going to continue to be the b value. And we're just going to put a 10 there. Now, really, this process ain't going to change. It's not changing at all. We've got a positive 24, and we've got a positive 10. So that tells us that this needs to be positive and this needs to be positive. That hasn't changed. We're still looking for 2 numbers that multiply together to be 24 and add up to be 10. So we look at our factors of 24 here on the side. 6 and 4. So I'm going to put a 6 here, and I'm going to put a 4 here. Now is where it changes. Okay, because again, don't write this. If I were to put, like we did it yesterday, x plus 6 and x plus 4, If we were to check this, I've got x squared plus 10x plus 24. Does that work? No, it's not the same thing. So we've got to change up how we do this a little bit. And this is where we're going to kind of do what we call splitting the middle term. So what we're going to do now at this step is we're going to do exactly that. We're going to split the middle term. We're going to leave this first term alone. We're going to leave that as 3x squared. This 10x right here is going to be replaced with this stuff over here. So this is going to be replaced with plus 6x plus 4x. I just got the numbers from over here, and we put the x with them to do that, and then we're going to put plus 8. So essentially what I've done is I've split that middle term into two things. I haven't changed the value of it because 6x plus 4x is 10x. I haven't done anything. But now what we have is we have 4 terms. And when we do things with 4 terms, we factor by grouping. So we're going to group now the first 2 terms together, and we're going to factor out a GCF. What's the GCF for 3x squared and 6x? 3x. So if I take 3x out of 3x squared, what do I have left? 1x, right? What's 6x divided by 3x? 3x plus 2. I'm going to move this down here a little bit. Everybody remember what we did was we divided each of these terms by that 3x. That's where we got inside that parentheses x plus 2. Plus, what's a common factor for the second part? 4 is a common factor, right? If I take a 4, so divide each of these by 4, I'm left with x plus 2, right? Notice how these two things are the same. Since those two things are the same, I can factor out that x plus 2, and then my other factor. If I take x plus 2 out of 3x, I'm left with 3x. If I take that out, I'm left with 4. This is my factored form of 3x squared plus 10x plus 8. And it's all about fixing that middle term, okay? And we kind of call splitting that middle term into 2 things. And we got to be able to do that. If we corrected this, and I needed to give myself more space. If we corrected this, if we'd seen if it was right, FOIL, x times 3x, 3x squared, x times 4, the outside, 4x, inside, 2 times 3x, 6x, last, 2 times 4 is 8. 3x squared plus 10x plus 8. It works. And this always works. It's a great way to do these A's, B's, and C's when your A value isn't 1. It's a great way to factor trinomials. Okay, so logical question. There's a logical question that comes up after this, right? So let's look at this again. It was 3x squared plus 8x plus, what was it, plus 10x? What was our problem? Plus 10x equals 8? Plus 8? This was it, right? And we did our little thing here, and we said this was 24, and we said this was 10. And we put 6 first, right? Yeah. What happens if I turn it around? What happens if I write 4 and 6 instead? Which is logical, right? Does it still work on our little thing? Yeah. So we can still, let's see what happens if we try to split that middle term. So now I might have 3x squared plus 4x plus 6x plus 8, right? Notice how I turned it around as it was last time? Still got 4 terms. Take out a GCF. What's the GCF? Just x, right? If I take an x out of each of these, I'm left with 3x plus 4, right? What's a common factor for 6x and 8? That gives me 3x plus 4. 3x plus 4, x plus 2. Is that the same thing we had last time? Yeah. Gosh, I hope it is, because if it isn't, I just made a fool of myself. Nope, it is. Moral of the story, doesn't matter if you turn it around. If you put it the other way, it's okay. You can still factor out that GCF. You're going to come up with the same answer. Most of you were getting really good at doing that. It's just the same thing. But now we have to rewrite that middle term. And we got to get used to rewriting that middle term. Okay, let's look at another example. Let's go with 4x squared minus 3x minus 10. We'll do it together. What number goes on the top? Negative 40. Why is it negative 40 instead of just negative 10? Because you have to take A times C. Don't forget to take A times C. What's my B value? Negative 3. So top is negative, so that tells me one of these is going to be negative and one of them is going to be positive. So we do our little doodle down here of 40. What are factors of 40 that have a difference of 3? I know what it is. So let's list the fact. 1 and 40, does that sound like it works? Does 2 go into 40? 8 and 5 work? 8 times 5 is 40, right? So if I use 8 and 5, 8 times 5 is 40, their difference is 3. Which one's positive, which one's negative? Which is positive, the 8 or the 5? The 8 is going to be negative, right? The 8 is going to be negative and the 5 is going to be positive. Negative 8 plus times 5 is negative 40. Negative 8 plus 5 is negative 3. It works. Step 1, done. Step 2, we're going to split the middle term. Leave the first term alone. 4x squared. My middle term is going to become negative 8x plus 5x. Again, I'm replacing my middle term with what's there. And then we're going to put minus 10. The 10, the first term and the last term, just drop straight down. Next step, factor by grouping. Group the first two together. What's the greatest common factor for 4x squared and 8x? So I'm going to divide each of these by 4x. So 4x, then a parentheses, x minus, what's 8x divided by 4x? 2? Perfect. What's a common factor for these last ones? 5. So I'm going to divide each of these by 5. 5x divided by 5 is x. Negative 10 divided by 5 is 2. Perfect. We've got exactly what we want. We're going to factor out an x minus 2. That leaves me with 4x plus 5. That right there is your solution. Double check it. 4 times x is 4x squared plus 5x minus 8x minus 10 works. Notice how this right here is the same as that right there. I wrote it in a different way, but same thing. Factoring by grouping, by splitting that middle term. I'm going to have you try the next one by yourselves. See how you do. Let's go 5x squared plus 7x minus 6. go ahead and factor that trinomial by splitting the middle term. First hour this morning, I was recording the videos like I always do. Turned on music while they were doing one of their problems, like you guys are doing now. Went to upload it to YouTube. You got denied because of the music in the background. I had to edit it. What a pain. I think it works. Copyright regulations. Somebody said you can play it for like 6 seconds and you're okay, but if you go to 7, you're bad. Or you go to 7 and you're good, and 8 you're bad. Something like that. Oh, geez, why did I put a 6 there? I was confused there for a minute. So 10 and 3, which one's positive, the 10 or the 3? The 10 is positive, 3 is negative. Now, little hint in here. I'm going to rewrite the 5x squared. I'm going to kind of think ahead a little bit. What does it make more sense to put after the 5? Because I know I'm going to group the first 2 terms together, right? What makes more sense to put next, the 3 or the 5? Or the 3 or the 10? The negative 3 or the positive 10? 10 probably makes more sense, right? Because 5 is a factor of 10. So I'm going to put plus 10x here. And then if I put minus 3, the 3 and the 6 go together well. Does it matter that I do that? No, it doesn't. If you don't do that, it's okay. I'm just kind of looking ahead going, I like GCFs. So greatest common factor there is 5, 5x. So divide each of these by 5x. That leaves me with x plus 2. Seems like we're getting x plus 2 a lot, doesn't it? It's not always x plus 2. What's the GCF now for the last set? 3, right? Make sure we take out a negative 3. That leaves me with x plus 2. So our factor, x plus 2, 5x minus 3. We're done. Okay. Any questions with that one? Anybody need a couple more seconds to write this one down? Move it up here for a couple seconds. Okay, next one. And again, done. I want you to do this one to see how you do. Let's go 6x squared plus 13x plus 6. Kind of story time as you're going through and doing this one. When I was essentially, I graduated from a really, really small school. I mean, if everybody's in this class room that's supposed to be here, that was the size of my graduating class. I graduated from North Central of Manly down in Manly, Iowa. Class size of, I was a little bigger than that. I think I graduated with 35 or 36 total kids. So our math, we didn't have like an honors track. We didn't have that. So everybody took algebra as ninth graders. When we were taught how to do this, it was all by guessing and checking. So we would have to just kind of start, we would put like something like x plus 2 times 6x plus 3 and see if it would work. And figure out if it worked. And then if it didn't work, we would have to try something else. We were kind of taught what's called a guess and check method, which remarkably enough, if you look on the internet for factoring trinomials with the a value not equal to 1, there is an amazing amount of videos where they do it like that. It's hard to do it that way. But you get good at your math facts. What number goes on the top? 36. What number goes on the bottom? 13. It's plus and plus, right? So 9 and 4. So 6x squared plus 9x plus 4x plus 6. Greatest common factor for 6x squared and 9x. 3x. 6 divided by 3 is 2. X squared divided by x is x. 9 divided by 3 is 3. X's go away. Plus 2. 4x divided by 2 is 2x. 6 divided by 2 is 3. Yay, it worked. 2x plus 3 times 3x plus 2. That's your solution and you're done. Most the answer to go back to your, do I make them up? Most of the time, but these I can't, because if I tried to make it up, it might not work. Because not all of them are factorable. So some of them don't work. Are we okay with this? Okay, so this is factoring, day 3, when a is not 1. We are going to do this again tomorrow. Okay, so you're going to get a little bit more practice on this tomorrow. Do you have a worksheet to do today? Yes. Do you have 16 problems on that worksheet today?
Yes.
No. Yes. Do you have to do all 16?
Yeah.
Yes. You've got 15 minutes to do it. Go.